Hello guys, this is the MEPtutor, and in today's video I'll be solving this problem. We have this inclined plane, we have three blocks, and we are looking for to calculate the tension of the rope that joins block A and block B. So one of the questions of the problem is to find tension 1. Other questions of the problem is to calculate the weight of the block C. And the data we have is that the weight of the block A is equal to the weight of the block B, which is 20 newtons. We know the kinetic coefficient of friction between each block with the surface is 0.5 without units, 0.5. And we know the block C descends, so the movement will be in this direction and with constant speed, so the acceleration will be equal to 0. Alright, let's solve the problem. First, we know that we can start from left to right with the block A. All the forces that interact in this diagram with the block A will be the normal force first. The normal force. We have the weight of the block A. We will have tension 1. Tension 1. Normal force. And we will have a friction in the opposite direction to the tension 1. So the sum of all these forces in the y-axis, because in the y-axis there is no movement, so it's static, so it's equal to 0. We only have the Newton, the normal force, sorry, minus the weight being equal to 0. So the normal force is equal to the weight A, which is 20 newtons. The sum in the x-axis, there is movement, so it's equal to mass times acceleration, but the acceleration is 0, so it's also equal to 0. We only have the tension 1 minus the friction. But we know that the friction is equal to the normal force times the coefficient of friction times 1. Alright. Times 5. And this is equal to 10 newtons. So the tension 1 will be equal to 10 newtons. That's the first question of the problem. 10 newtons. What else do we know? We know that the block B is on the inclined plane. It's a little bit less inclined than this, like this. We got the block B in this position, block B. And in the block B, there will be also a normal force. There will be a tension 2. There will be tension 1 here. But it also is going to be a friction force. In this case, it's friction 2. And also the weight of the block. The normal force is perpendicular always to the surface. So here we got our the weight B. Let's draw that, weight B. Alright, in this case, it's convenient for us to put the reference, the axis, inclined, as most of the forces are. So this will be the y-axis, and this will be the x-axis. In this case, the weight must be decomposed into two components. The weight B in the y-axis. We know that this angle here is 37 degrees. So this is also 37 degrees. So this is the adjacent. So the weight B will be the weight, the weight B in the y-axis is the weight B times the cosine of 37 degrees. Due to geometry, trigonometry. All right, the weight B in the x-axis, x, will be the opposite side of the triangle to the angle. So the x-axis will be weight B times sine of 37 degrees. So we can sum all the forces. The y-axis is also 0, there's no movement, and we only have the normal force minus the weight B in the y-axis and equal to 0. So this is equal to, let me see, the normal force will be equal to 15.97 newtons. Then in the x-axis, it happens again the same. The acceleration is constant because all the blocks are interconnected. That means all the blocks have the same speed, the same acceleration. So it's also 2 mass times acceleration. Acceleration is equal to 0. We have the tension 2 being positive because it's in the direction of the movement. This is the direction of the movement. Minus tension 1 minus friction minus the weight in the x-axis. This is equal to 0. And we got that the tension 2 will be equal to the tension 1, we know it's 10 newtons, plus the weight B in the x-axis, which is 12.03 newtons, plus the friction force. The friction force, again, this second is friction force 2. Friction force 2 will be equal to the normal force times the coefficient of friction. And that it's going to be equal to 7.98 newtons. All right. And so let's put this here. And if we sum all of this, we get a tension 2 equal to 30.01 newtons. Finally, to solve the problem, we can do the diagram of the block C because we're looking for the weight of the block C. And it's going to be the tension 2, and here the weight C. We can observe that in the x-axis there is nothing, but in the y-axis we got that the tension 2 minus the weight is equal to 0. So the weight C is going to be equal to the tension 2, which is 30.01 newtons. And that's all the problem. 30.01 newtons. Thanks for your time.